The other parts on tonight's homework ask us to graph inequalities. And so I got a couple examples of each type of set of directions you'll see. First set says graph the solutions of each linear inequality. So all you're going to do is start with that y-intercept, which is -5. So to go down 5 spaces, 1, 2, 3, 4, 5, and put a dot. And now use the slope. So the slope is 3 to 1. So you're just going to go up 1, 2, 3 over to the right 1 space. Do that again, maybe a few times. Get a bunch of points to represent that line, and then go ahead and figure out the shading. And so the shading works this way. Well, first of all, let's do the line type. Line type, no line underneath, so that means it's a dashed line. So what that means is the points on the line are not solutions. But if we look at the inequality sign, it says positive y is less. Less, this symbol, another word for that is smaller. So what you do is you go to one of these points that's on the line here. This y value is 7. So that means that the y values need to be less than this y value. That means it's down in this direction. Or this y value is -2. And so that means that I need to have the y values smaller than -2 from that point. So that means they're below. And so everything on this side of the line represents a true solution for that inequality. So that's why we shade in that direction. Let's take a look at the next one, positive 1's, the y-intercept this time. So we start up there, use the slope. This time it's a down 1, right 2. Down 1, right 2. That's what the slope is telling us. So always follow what that number is in front of x as long as the y is by itself. So again, just down 1, right 2, or up 1, left 2. That gets you on that same line. So looking at the line type here, we've got a solid line because that line is underneath. So we'll go ahead and use that solid line to represent that the points on the line now are solutions. Well, here it says positive y is greater than. Greater, another word for that is bigger. In bigger, we're talking about y values. So look at a point. This y value is, let's see, 4. And so that means the y values need to be bigger than this y value. So they're up above that one. This y value is smaller, but all the y values need to be bigger than it. So this y value is -2. All the y values need to be bigger. So they go in that direction. So all the points on this side of the line are possible solutions. So we use these concepts to now graph systems of linear inequalities. So let's take a look at our first one here. We're going to start by graphing this point. We go down 2 spaces, and then we use the slope. The slope is -1 to 1, so that means down and then to the right. You can do that a few times. You can also go the other way, up and to the left. Gets you on that same line. Well, it's a dashed line because there is no line underneath that inequality sign. So we'll go ahead and draw that. Now let's figure out the shading. It says positive y is less. Less means smaller. And so all the y values need to be smaller than a point that you're on this line. So if I'm on this point here, a y value somewhere around -5 needs to be smaller. That means I'm going to draw it down. Now, instead of shading it, let's see what we do for the next line. So for this one, I need to move that 3x over first. Always get y by itself. So let's rewrite what we've got. Y is greater than -3x plus 1. Let's start that y-intercept, up 1 space, and then use the slope. Down 3, left 1. So you do that another time or two. Down 3, left 1. And we can kind of see that this line's going to continue on this direction. But I'm running out of room, so I've got to stop and draw that line. Well, this equation has a y being greater. Y being greater means that I need bigger y's. And so bigger than the number that I'm at. So for instance, if I'm on this point right here, which is 4 spaces up, the y values need to be bigger than it. Any other y value needs to be bigger than this one. So I need to shade in this direction. But I can't shade here because it needs to be below this blue line. So the only area is in this small region down in here, which works for both. Well, we've got another example here. And this one, again, has one that's already solved for us, or y is by itself, so we start with that y-intercept of -2, and then use the slope. The slope is 2 to 1, so up 2 over 1 space each time. Gets you on that line. We could also go the other way, down 2, left 1. Gets us on that line, and then we go ahead and draw the line. Now this, again, is a solid line, because the points on the line are solutions. That's what it tells us here, because of the line underneath. And now we go ahead and solve this one. So here on this next one, we've got to isolate y. So I've got 2 steps to do here. You'll see that shortly. So first step was to subtract that x from both sides. So now I have this. Y is greater. Actually, it's a negative y. Look at the sign here. Negative y is greater than negative x. And so from there, all I have to do is divide by that -1. Now remember, when you divide by a negative, and you've got inequalities, everything changes. It's now y is less than positive x. So we start at that y-intercept right here, and then use the slope. The slope is 1 to 1. So we're just going up 1 and over 1. Up 1 over 1. So it ends up looking like this. We can also go the other way, down and then to the left. And then we draw the line. This is a dashed line. And put arrows at the end. And now let's figure out the shading. Well, we'll have to figure out the blue line as well. So here we have y is less. Less means it needs to be smaller y's. So you're going to shade below that black line. Let's go back to the blue line. And this was a positive y is greater. Greater means that there need to be bigger y values. So where do they agree? Right in this region here. And there's our answer. Well, those are the last 2 types of problems. Good luck on tonight's homework.